Have you ever gazed into the cosmos and wondered about the breathtaking beauty and complexity of the universe? From the dance of galaxies to the explosive birth of stars, today's journey takes us through some of the most awe-inspiring cosmic phenomena ever captured. Let's dive into the universe through the lenses of the Hubble and James Webb Space Telescopes. Two spiral galaxies take the shape of a colorful beaded mask that sits above the nose and is angled from top left to bottom right. The galaxy at left, IC 2163, is smaller, taking up a little over a quarter of the view. The galaxy at right, NGC 2207, takes up half the view. IC 2163 has a bright white core with two prominent white spiral arms that rotate counterclockwise and become straighter toward the ends. Its arms are dotted with pink. NGC 2207 has a very bright core that is larger. Overall, it appears to have thicker spiral arms that spin counterclockwise. This galaxy also contains more pink areas of star formation. In the middle, the galaxy's arms appear to overlap. The black background of space shows extremely distant galaxies that are tiny and often red and orange smudges, as well as a few blue foreground stars. Two views of the same object are shown side by side, split evenly. The Hubble observation is at left, and the Webb observation is at right. Both show an angled pair of spiral galaxies, IC 2163 at top left and NGC 2207 at bottom right. IC 2163 is smaller than NGC 2207, and they appear to be overlapping at the center diagonal. In the Hubble image, the galaxy's cores appear white at the center and more orange overall. Both galaxies have bright blue spiral arms and are interlaced with dark brown irregular dust lanes. Tiny galaxies and a few foreground stars dot the black background of space. There are no data along the bottom left, top right, and bottom right corners. In the Webb image, the galaxy's cores appear bright white, transitioning to spiral arms that are also bright white, but flecked with pink dots. Tiny galaxies and a few foreground stars dot the entire black background of space. These eyes are actually the cores of two galaxies. The smaller spiral galaxy on the left is IC 2163. It has been slowly creeping behind the larger galaxy, NGC 2207. It's possible this pair will swing by one another repeatedly over the course of many millions of years. Their cores and arms might eventually meld, leaving behind completely reshaped arms and an even brighter Cyclops-like eye at the core. A large spiral galaxy takes up the entirety of the image. The core is mostly bright white, but there are also swirling, detailed structures that resemble water circling a drain. There is small white and pale blue light that emanates from stars and dust at the core's center, but it is tightly limited to the core. The rings feature colors of deep red and orange and highlight filaments of dust around cavernous black bubbles. A star cluster is shown inside a large nebula of many-colored gas and dust. The material forms dark ridges and peaks of gas and dust surrounding the cluster, lit on the inner side, while layers of diffuse translucent clouds blanket over them. Around and within the gas, a huge number of distant galaxies can be seen, some quite large, as well as a few stars nearer to us which are very large and bright. A dense cluster of bright stars, each with 6 large and 2 small diffraction spikes due to the telescope's optics. They have a variety of sizes depending on their brightness and distance from us in the cluster, and different colors reflecting different types of star. Patches of billowing red gas can be seen in and around the cluster, lit up by the stars. Small stars in the cluster blend into a background of distant stars and galaxies on black. Artist's concept of Centaur 29P, Schwarzmann-Bachmann 1, as seen from the side against a dark, mostly starless swath of space. The rocky, bilobed nucleus is toward the right and resembles the simplified shape of a peanut. The left side of the Centaur is partially illuminated by the sun, which is off-screen, revealing the nucleus's light brown surface. 4 jets of gas, depicted as translucent cones of white, emanate from various points on the Centaur's surface and extend beyond the frame. 2 emanate upward from the top, 1 jet spews from the bottom and extends downward, and 1 jet emanates from the left side of the nucleus and extends toward the left. This picture is set into 2 equal frames, left and right. Both are set on a black backdrop full of luminous, bright spiral galaxies of varying size, glowing bright white, yellow, and orange. Many of these galaxies are either clustered together or overlapping each other visually, adding layers of scale to the image. In the middle of the left frame, 2 bright, prominent orange galaxies appear to be stretched out into long tendrils pointing north and south that appear roughly 1/3 the size of the frame, much unlike the usual spiral form of galaxies in space. These two orange elongated galaxies are the focus of this image, while many different colored galaxies populate the background. The left frame has a square inset, highlighting one of the two elongated orange prominent galaxies, which is the focus of the image. This shows the magnifying effect a foreground cluster can have on the distant universe beyond, known as gravitational lensing. The lens, consisting of a cluster of galaxies that is situated between the supernova and us, bends the supernova's light into multiple images. To achieve 3 images, the light traveled along 3 different paths. Since each path had a different length, and light traveled at the same speed, the supernova was imaged in this Webb observation at 3 different times during its explosion. The right panel zooms in on the long orange filament, revealing 3 focal points of concentrated light that have been marked with circles. Analyses confirmed that these dots corresponded to an exploding star, one with rare qualities. First, it's a type Ia supernova, an explosion of a white dwarf star. This type of supernova is generally called a standard candle, meaning that the supernova had a known intrinsic brightness. A black background sprinkled with small colorful galaxies in orange, blue, and white. On the left, a third of the way down from the top of the image, a very faint dot of a galaxy is outlined with a white square and pulled out in a graphic to be shown magnified. In the pull-out square to the right, the galaxy is a hazy white dot edged in orange, with faint blue projections opposite each other at the 11 o'clock and 5 o'clock positions. An artist's depiction of Webb floats above Webb imagery that spells out the number 1000 against a black backdrop of galaxies and stars in blue and orange. The number 1 is a stretched-out orange-lensed galaxy. The first 0 is the Southern Ring Nebula, with a roughly circular cavity filled with aqua-colored gas surrounded by a ring of red gas, with a star at the center. The second 0 is a mid-infrared image of merging galaxy pair ARP 107, like a ghostly blue wagon wheel with a bright center. The final 0 is Jupiter, striped in grayish blue and beige with green and orange glows at the poles due to auroras. The universe is vast, and every image reveals a new story waiting to be told. Subscribe to Stellar Science for more adventures into the cosmos, and hit the like button if you love unraveling the mysteries of space. Until next time, keep looking up and stay curious about the stars.